All right, guys, we're now going to talk about our more about our radical operations, and we're going to continue on with squaring them and rationalizing. The rationalizing is really, really important here. We're going to see that later on in the unit. Again, just a reminder, get these memorized, as many as possible. Squaring. What we need to understand here is squaring a number and taking the square root, which we should already know. They are inverse or opposite operations. We learned this with Pythagorean theorem. When we have c squared equals a number, we have to square to undo that c squared. What happens is the squaring and the square root are going to cancel each other out. So sometimes you're going to get a problem that is as simple as the square root of 25 squared. What happens is these cancel out and you're left with 25 as your answer. Done. That's it. Awesome. Take a look at B. Do B on your own. Pause it. You should be able to be on your own. We just did it. We're just going to cancel that square with the square root, the radical sign, and we're just going to end up with 18. Now, when you have a whole number in front, or keep in mind this is not the index that we talked about in the last set of notes. The index is just a little tiny number up here. We're talking about a whole number in front. You're going to have to basically distribute that square. It's not even basically, you are. You're going to have to distribute that square to that 2 in front, the whole number, and you're going to have to actually square that number, okay? And that's going to give us 4. And then when you distribute that square to the square root, remember that cancels it out, giving us a 5, a whole number of 5. So we just multiply them. Just like when you have 2x, it's 2 times x. When you have 2 square root of 5, it's 2 times the square root of 5. I don't know if you saw in the calculator in the last video, whenever I had the whole number in front, it breaks it down to 24 times the square root of 2, because that's all we're doing. So when you cancel out that radical sign, you have to make sure you multiply these, and our answer comes out to just 20. So pause and try the other one on your own. The exact same process here. Going to take that square, distribute it to the 4, and this is 4 squared is going to give me 16. Again, have it memorized. Great idea. We're going to multiply it once we cancel this out by that 2, and we're going to get an answer of 32. So that's all that's happening with the squaring. Okay? Not swearing, but squaring. Rationalizing. I like the rationalizing. I don't know, call me weird, whatever. What ends up happening here is if we end up with a radical in the denominator, that is a no-no. We are not allowed to do that. So we have to get rid of it. One way you can do this is you can multiply both the numerator and denominator by that radical. Okay? The other way you can do it, the shortcut that I'll show you, is called shove it and leave it. So the first 3, I'm going to show you both of them. And then the last 6, I'm going to do just the shove it and leave it. So what we're talking about here, multiply both the numerator and denominator by that radical. The radical in the bottom here, that square root of 3 that we need to get rid of, we're going to multiply both the top and the bottom by the square root of 3. We didn't talk about multiplying radicals, but all it is just like dividing. You're going to multiply radicals with radicals, whole numbers with whole numbers. So here we have the square root of 2 times the square root of 3 is going to give me the square root of 6 over the square root of 3 times the square root of 3 is the square root of 9. What happens here is you end up with a perfect square in the denominator. So then square root of 6 stays, the square root of 9 is 3, and there's your answer. The shove it and leave it part, okay? Write this shove it and leave it. You're going to take what you have, the square root of 2 over the square root of 3, all right? You're going to leave that, the square root of 2 doesn't move. You're going to shove that radical in the denominator. You're going to shove that to the top. And you're going to leave the number by itself in the bottom. You're just going to leave the number without, that's the leave it. Leave it by itself. So then all we have to do on the top is just multiply those two, which is exactly what we did up here, isn't it? So we multiply those two, we get the square root of 6, and then we just ended up with the square root of 9 that turned into 3, and it's just a lot easier. It's 2 steps, done. I really, really like the shove it and leave it part of this. Next, do this next problem, okay? Again, let's do our multiply. We're going to multiply both the top and the bottom by that radical that's on the bottom, the square root of 2. Up here, the 2 on the outside, the whole number stays there. And then we're going to multiply the square root of 5 times the square root of 2 to get the square root of 10. And then the square root of 2 times the square root of 2 is going to give me the square root of 4, which is then going to, I'm going to bring it down here, is going to, the square root of 4 is your perfect square, so you end up with square root of a 2 square root of 10 over 2. Now, you always need to keep an eye out for this. These two right here are going to cancel each other out, and leaving you with just the answer of the square root of 10. So let's look at the shove it and leave it. We have 2 square root of 5 over the square root of 2. Up top, we still have the 2 square root of 5. We're going to shove that square root of 2 up to the top, multiplying it with the square root of 5, and then we're going to leave the 2 on bottom, all by itself. So again, here we have 2 square root of 10 now over 2, canceling those the 2 2's out, 2 2's, leaving us with the square root of 10. So when you get something like this, we need to realize that when we were doing the dividing, we would, this right here and this, an A, it's the same thing. We just put the radical sign over the whole thing. So what we want to do here is we want to separate this to the square root of 4 over the square root of 3. So if we go and we also need to see if the square root of 4 is a perfect square. So we need to simplify that. We're going to get 2 square root of 3. This is a little bit different. So let's take the 2 square root of 3, and let's go ahead and multiply both the top and the bottom by the square root of 3. Up top, we're going to have 2 square root of 3. On bottom, square root of 3 times the square root of 3 gives you the square root of 9. There's our perfect square. Square root of 9 is 3. Now you cannot simplify 2 over 3, so we'll just leave it as is. Our shove it and leave it. Okay, I'm just going to go ahead and start with the 2 square root of 3 because we know that's what this is going to boil down to. So we're going to have 2 square root of 3. Let's go ahead, we've got our 2 on top. We're going to shove that radical up to the top, square root of 3, and we're going to leave the number by itself. See how much easier that was? Okay, so again, pick whichever one that you want. I'm going to continue now with just the shove it and leave it portion of it. Here I've got the square root of 12. I'm sorry, I've got 12 over the square root of 2. So I'm going to rewrite so I can shove it and leave it. 12 over the square root of 2. 12 stays up top. I'm going to shove that square root of 2 up there, and I'm going to leave the 2 on bottom. Always double check. See if you can simplify. 12 divided by 2 is going to give me 6 square root of 2, so we don't even have a fraction anymore. And again, you can always go in the calculator and you can check these. Press your control divide for your fraction function. Okay, I bring the calculator in. If you press control divide, it's going to bring that yellow little fraction thing. Control divide brings up a fraction. If we plug in 12 in the top, we scroll down, we put the square root of 2 in the bottom. This is what we get as a decimal. Now let's put 6 square root of 2 in. 6 square root of 2. And bada bing, I know that I did the correct thing here. All right. Next, let's take a look at 8 square root of 12 over square root of 8. So here, I'm going to rewrite it. This one is going to be a little bit of work, so I'm going to write it way over here. 8 square root of 12 over the square root of 8. I'm going to go ahead and leave that 8 square root of 12 up here. I'm going to shove that square root of 8 up to the top, and I'm going to leave the 8 by itself on the bottom. Now, whether you want to cancel this out right now, you can, or you can just go ahead and say, okay, we have 8 square root of 12 times 8 is going to give me 96. That's a really big number. Something tells me we could probably simplify that. And we're going to have that over 8. Well, these two are going to cancel out, and coming down here, we're going to have the square root of 96. So I'm going to do the division tower. You can do the factoring if you want. I'm going to take 96. Smallest prime number 2. Yep, can divide it by that. I get 48. I can divide by 2 again, 24. 24 divided by 2 is 12. Lots of 2's here. 12 divided by 2 is 6. 6 divided by 2 is 3. I've got a prime number at the top. So I'm done factoring. So we're going to take all of our partners. Here's a partner here, 2. Times, here's a partner here, 2. No more partners. 2 and 3 are completely different sizes. They cannot team up on a three-legged race. So they're going to go inside, and we multiply the numbers on the inside. So once we do the multiplication, 2 times 2 gives us 4. Square root of 2 times 3, 6. And again, you can always go check on the calculator and see if both of those come out the exact same, what we had at the beginning and once we've rationalized. Next, 7 square root of 3. I'm going to rewrite it so I can rationalize, shove it and leave it. I've got my 7 on top. I'm going to shove that square root of 3 up top, and I'm going to leave the 3 all by itself on the bottom. 3 square root of 3 is simplified. 7 over 3 is simplified. We're done. Love these easy ones. Next, letter G. Do I shove it and leave it? So here's my 5 square root of 10. Leave it. 5 goes up there. Shove that square root of 10 up to the top. Leave the 10 by itself on the bottom. Now, we could simplify 5 over 10 to 1/2. So when we do that 1/2, we have the 1 square root of 10 over 10. Problem is we don't put the 1, just like we don't put a 1 in front of x. Maybe this look more like a radical sign. We don't put a 1 in front of there. We know there's an invisible 1. So your answer would just be square root of 10 over 10. Sorry, that should be a 2. Square root of 10 over 2. I was looking at my answer key and realized I did my answer key wrong. So we're going to have that 1/2, but we don't put that 1, so we just have the square root of 10 over 2. And we're done. So for the next one, let's see which color I want to use. We'll go ahead and bring this down, recopy, so we can do our shove it and leave it. 1 over the square root of 2. We're going to have that 1 up top. We're going to shove that square root of 2 up top, leave the 2 by itself. There's a shove it and leave it. And again, we wind up in the situation with the 1 in front. We don't write that. We just go ahead and get rid of that 1. We never put a 1 in front of the radical. So we wind up with the square root of 2. Make that a little bit neater for you. Square root of 2 over 2. All right, the next one, we are going to have a little bit of work to do here. Okay, no big deal. Let's go ahead and take a look at how we're going to get through this guy. We've got our 8 square root of 3 over the square root of 21. So keep that 8 square root of 3 here. We're going to shove the square root of 21 up top, and we're going to leave 21 on bottom. Now when I multiply the 3 times the 21, I'm going to wind up with 8 square root of 63 all over 21. Now we need to factor out that 63. Okay, so that's 63. If I do my division tower, I cannot divide by 2, but I can divide by 3, and I get 21. Cannot divide by 2, but I can divide by the next prime number, 3, and I get 7. So now we have a prime number up top. Let's find our pairs. We have a pair of 3's right here. Excuse me. Let me bring it down here. So 3 is going to go on the outside with that 8. Don't forget that 8 was already there. Okay, the 3 is going to go on the outside with that, and the 7 is going to remain on the inside by itself. And this is all still over that 21. 8 times 3 is going to give me 24 square root of 7, all over 21. Now, the 24 and the 21 can both be divided by 3, so we need to simplify that. So these two right here, we can simplify this fraction. 24 divided by 3 is going to give me 8 square root of 7. Over 21 divided by 3 is 7. You cannot do anything with the square root of 7 and 7 because it's apples and oranges. So here we are done, and that is the end of our notes for radicals.